Hello, and welcome to the Sundays portion of our Lighting for Programmers presentation. It's more than just button pushing, fundamentals for the aspiring lighting programmer. Today's program is intended for rigging and shooting electricians who look to improve upon their skills and step up into the role of lighting programmer, also sentimentally known as the dimmer operator. This class will move fast, and we have a lot of material to get through. There are some good examples of solid practices employed by both of us throughout. Please ask questions at any point, and one of us will reply in the Q&A window or interrupt for a live answer.
Quick question. Do I have the right one on? This is editing.
Yeah,
Okay,
we are in session 2. Yep.
great. All right. Well, thanks again for those who joined us yesterday and for coming back. We are going to dive into a discussion of both the hardware and software that make up our lighting systems, and then we'll begin to look at the digital representation of the paper concepts we discussed in the previous class session. We also just want to make this disclaimer. We mention a lot of products that we have used throughout our careers on these things, and but we don't specifically endorse any product in particular as we go. So I got the whole fun thing Zoom going here today. I need to like actually turn on my
Get that camera going.
Hey guys, hello.
Go.
Good start to the Sunday. All right, here we go. Okay, great. So a quick review. We want to discuss the circuit, which is the name of the physical slot of distributed power. So when we spoke yesterday, example B2, when dealing with a multi-cable or sockopex, that would be, we said A would be 1 through 6, B would be 7 through 12. So B2 would be that circuit, which would typically route to dimmer, dimmer 7. Next, the dimmer, what we're talking about is typically a device in a series of many in a rack or by itself that regulates the control of electricity to an instrument. It can also refer to a starting address on a simple device or a legacy console. So the example here is our ETC sensor rack has 96 individual 2.4K dimmers in it. The address, when we're talking about address, and we'll get into this much more with the patch today, is a number between 1 and 512, which establishes the starting address of which data the device will receive from a lighting console and by which patching is completed. So typically now that includes a universe assignment followed by a starting address. So when I was talking about the BIs yesterday, the moving light, the start address being universe 8, address 1. And finally, the channel or the fixture ID is the individual light or device that can have a user-determined value and how a console will actually call up and assign the value. Groups are combinations of channels. So for instance, I like all my strobes to start at channel 1001, and I can call up all my strobes in group 1000. So that's a quick review.
Cool. So today we're going to be bringing up examples from the 3 main consoles you'll see out there: ETC EOS, HOG4, and MA2. The lighting community generally accepts that any console can provide any cue or look needed for a particular situation. However, it is often the time needed in the method of programming that cue in which the consoles can differ. You can go from 0 to 100 in EOS pretty quick. HOG4 is a bit in between EOS and MA2. You can do a bit more, but it helps to have some pre-program time. And MA2 definitely takes a solid amount of time to pre-program for a lot of situations. Most console programmers do have a default show for the consoles of their choice with a variety of pre-programming already complete. We'll talk about EOS a little bit first. Ion is the console of choice in most high school and college theaters and is a gold standard in educational institutes across the US. It's also seen a lot in our TV sets, and many of you who have some experience will recognize some of these desks. They've been a strong player in the lighting field since 1975, and their customer service is absolutely 100% top notch. As long as you have a serial number on your gear, they will take your call and spend as much time on the phone with you to help you solve your problems. Hog is fairly popular in corporate as well as in theater and concert. It's sometimes described as a cross between EOS and MA2 and is a great console to start out on for busking concerts. Hog is now on its fourth iteration, Hog 4, and it's proving itself to be fairly strong in the media world. It was recently acquired by ETC, and they seem to intend it to be the more entertainment concert console of their console lines. Grand MA is a worldwide standard in concert production and has a very strong showing in film as well. You may have heard that they recently released Grand MA3. Fortunately, Grand MA2 is still pretty much the standard, and MA3 won't be adopted by the lighting community for probably another year or two. So if you're looking to learn Grand MA, learn Grand MA2, and the skills will mostly transfer over to Grand MA3 once those become a bit more common. It's definitely a bit more on the complex side of programming, but with that comes a certain amount of flexibility. Here we see Eurovision, which is typically known as the largest lighting production every year in the world. We have a list of other consoles that we'll just kind of bring up here. A lot of them do a lot of different things. Christmas light, I think I got Light Jams is pretty popular in the Christmas lighting community. If you've ever seen those crazy displays on houses, Shams's Magic Q is becoming pretty popular. I think you can even get the program and output ArtNet and streaming ACN for free from a computer. You know, we have stuff like Leprechaun right there, which is pretty old school for the old 12-channel light boards. And there's, you know, not an exhaustive list here. There's a lot of custom builds out there. The Super Bowl actually uses a custom build from PRG along with Grand MA2. So you'll see some stuff out there, but a quick list.
And I would say in our business on location, a lot of times when we're shooting at nightclubs or spots like that, you will find systems like the Light Jockey and that type of thing, and you have to either be able to adapt to running their system and or be able to patch their lighting into your own system.
Absolutely. So you won't be expected to know all those consoles, but know that they exist. And if you're thinking about buying a console, look over everything and get an idea of what you think you might want.
Okay, so diving right in now to our hardware. All consoles have a specific total number of outputs or universes they can natively control. That's their onboard system without system expansion. So with sets becoming more complicated and massive amounts of intelligent fixtures and LED units, this native value is eclipsed rather quickly, leading us to system expansion. But as you can see here for physical outputs, just have a couple of examples. The Hedgehog 4, which is from High-End Systems, has, you can see two physical outputs here, two universes. The Geo lighting console from ETC, we see has four universes, and this is that these have the 5-pin XLR, you know, DMX outputs, which we've talked about a lot before. The MA2 console here we see stepped up has a total of 6 outputs there labeled, you know, A, B, C, D, E, and F. Also to note that each of these consoles does have a jack for Ethernet, which is how we lead into the system expansion on these specific consoles. So let's talk about system expansion a little bit. What this is adding hardware to expand the physical amount outputs of a certain lighting console, which creates your lighting LAN, local area network, which we discussed a lot in the last class, and other classes you've probably been to. So as you saw in the picture before, all the consoles had the Ethernet outputs as well. A lot of systems have a proprietary Ethernet protocol to talk to gateways or nodes, and now the definition of gateway or node is a device that accepts one data protocol and converts it to another. For example, with high-end systems, they have a proprietary protocol called HogNet, and that HogNet is then converted in what's called the last mile to DMX, which coming out of your processor would be that DMX cable that we're all used to. So on the lighting, on the LAN, you typically use a dumb or unmanaged switch, probably say unmanaged switch before dumb switch. But that again allows all the devices to be together on the same network. We talked about the IP address and the subnet mask for that needing to match. We're not going to dive too far into all that in this because it's not specifically a networking class. But know that a complex network of multiple protocols can be achieved through smart or managed switches through VPNs. But typically, and others will say this, it's best practice to keep the protocols on separate switching. And I don't know, I think we said, feel free to ask questions, throughout if there's anywhere you want to stop and ask a question about it. Dom will be monitoring that for us. So here we have some specific system expansion devices for each of the consoles we've been talking about so far. Talking about IP address and subnet mask. For us, even on our simple systems, all the way up through the complex, concert systems, like what might be on a Beyonce concert or even bigger, or the Eurovision, static IPs ruled the day for us. That way, we never have a problem with the things like the DHCP server sending out sort of bad information to everyone and devices getting confused. You can map it out and chart it out just like a lighting plot. You have to have a network plot, and each of these devices needs to have its unique IP address on the same subnet mask to make your lighting area a local network work. So the point is we're adding the physical processing, and it greatly increases the amount of fixtures and parameters you can control, as well as system bandwidth and processing speed. Each of these nodes or gateways is a computer in its own right, and it's accepting Ethernet through a chosen protocol and outputting DMX data, like again, we call the last mile. But many of these accept multiple protocols simultaneously. So here we have the ETC Net3 gateway, which is typically an SACN, streaming ACN gateway. We have the DP8000, which is the data processor 8000, which is for the high-end systems expansion, and then the MPU for the Grand MA line. And many of these boards have a finite amount of parameters you can control, but some of these, it's almost gets to be unlimited as you stack processors on top of each other. As long as your network can handle the processing, so can your lighting console. Great.
Let's talk a little bit about desk remotes. You should find out from your primary op if a remote is to be used or expected on set. Again, going back to the questions that you need to ask the primary op before you find yourself in the role of dimmer op. Many gaffers and DPs like to have you by their side when mixing colors or setting levels or looking at cues. Typically, all consoles can be manipulated wirelessly with a tablet base map, which offers many of the functions of the full console in a compact package. Let's take a look at a couple of these.
Right. So we have some, there are some manufacturer developer specific programs like the ETC IRFR or the HOG4 remote from Numio. Another, and that's represented here. Here's the HOG4 remote. Here's the ETC IRFR, which you can actually, most of these apps you can install on your phone or your iPad or any of your smart devices or tablets. Another popular ETC remote, which is used a lot, is the one from Alien Stagecraft, which just actually has an MA style console layout. And again, this is all, touchscreen, so you're able to switch back and forth between the functions of the console itself. There's another transmittable protocol we're not going to get really that far into, but it's called OSC, Open Sound Control, which is, it allows a code-based wireless protocol to be sent between devices, i.e. the console and the remote. And it kind of works the same way as there's a transmitter and a receiver, but it's all through your basic wireless, your wireless feed. So again, when we started to talk about this idea that you're gaining the knowledge to become a substitute board op or just just stepping in while the primary board op has something else they have to get accomplished. So again, you want to know what you're walking into, and we can all of us who do this for a living can speak from the experience. And the ETC guys echoed this yesterday too. The biggest issue with wireless remotes is losing connection and how to reconnect when this happens. And the idea here is wireless works great until it doesn't, right? So you don't want to blow a cue on set when you could have been sitting at the console. You know, time is money on set, right? So you don't want to have that problem because of wireless issues. So speaking of wireless issues, we're going to talk about wireless DMX. So this is, let's take a minute to discuss how signal is transmitted and some common wireless gear you might encounter on set. The two components of wireless are the transmitter or transceiver, TX, and the receiver, RX. So the key concepts when we're talking about wireless data transmission are line of sight, number one, broadcast range, number two, antenna selection, number three, and the antennas we'll talk about omnidirectional versus directional. And number four is the frequency band that you're on. So from someone who does deal with this, this is probably one of the most difficult protocols to manage. And I know there's many other seminars about your wireless for your camera systems or your Teradek, the wireless for sound. And so all this understanding on a film set, all this stuff has to play really nice with each other when it's there. So here we go. Most wireless DMX can be configured to run on several bandwidths. So there's many pros and many cons. 2.4 gigahertz is the most common and the most crowded, but it will broadcast the furthest. Much of the advantage of complex tech and wireless data routing is the ability to coexist with other gear and limit the range of frequency it operates and the power it transmits at. That basically meaning a real life example is typically the focus pullers on set who are using the remote focus device for the cameras. They run on a specific bandwidth on that 2.4 gigahertz range. I think some of them, not all, obviously. But in this way, if your antenna power is too strong, you're actually going to be perhaps stomping out their signal, and you need to make, as a lighting IT person, which you now are, you're not only a lighting programmer, you are a dedicated IT person when you start to get into wireless networking. You have to make sure that your signal is not stomping out their signal and that everybody's playing nice together. So that 2.4 range, you can see here, and I think a lot of people know this because this is stuff you have to deal with at home too. There's the 11 channels in the 2.4 range. Obviously the channels after 11 are reserved for other things. And so a lot of our devices, including like the Centena AKS, you're able to pick which channel you operate on. For those of us who had our at-home networks like Apple airports and that sort of thing, you can pick which channel they operate on in that 2.4 range, so you can try to find a channel that's not as busy in your area. So then when we talk about the 5.0 gigahertz, it's cleaner, but the throw is shorter and camera lives here. So that's kind of scary, right? We don't want to be up in camera's business, especially in the TV and film industry. The 900 megahertz range, which is down here in this example, is less crowded and more universes can be transmitted. So this is kind of like the newest stuff, and you have to have even more specialized gear to buy, and it's not acceptable to many other manufacturers who've included internal wireless systems in their lighting instruments. So we know, like these days, like the Sky Panel 360s have an internal wireless. The KinoFlow Ballast also have internal wireless. So we have that there. Basically, this 900 megahertz band is kind of like where the home ham radio user would be in that bandwidth. So FHSS, how does it work? This is frequency hopping spread spectrum, which is kind of a fun term. with having the transmitters and receivers in sync. So what happens is on a given bandwidth, the transmitter will hop around many times within a second to find a clean channel or frequency. All universe data is broadcast. Newer hopping technology explores sending only changes to save on bandwidth, kind of like the newest Ethernet protocols do. So it's not so much a broadcast, it's only sending the changes out that it would be. Because as we know, data itself from the lighting console, typically, if it's just DMX, it's just a continuous stream of data. So basically, yeah, in our channel spectrum here, you can see the sort of hop pattern. We got 1 here, 2 here. So it's jumping all around, trying to find the cleanest path at a given time. And again, this is the hertz, it's many, many times a second. Next super important thing to talk about with this is the output power and antennas. So basically, the thesis here is lower power will crap out and higher power will cause more interference and radiation, which can debilitate some equipment and even other transmitters of the like. So on our devices, we do have the ability, on several of them, we do have the ability to change antenna strength. But there is probably like a safer area, you know, all the way down, you know, from, I think it's, yeah, 3.2 milliwatts to 500 milliwatts. 500 milliwatts is like crazy. You're just pushing an insane amount of radiation there. So you don't really want to jump up to that range. The other thing is very, very important and could speak from a lot of experience is the omnidirectional versus directional antennas. Omnidirectional is most standard gear, and it does serve the wide range of purposes, and is typically what we run into most days when we're talking about the Centena system with the AKS, or even the show babies, or even what comes with wireless solutions, WDMX. It's all typically shipped with omnidirectional antennas. And you can see the radiation pattern down here. It's kind of, if you think about your antenna, an entire, it's funny with those background. You think about the entire sphere around the antenna you're looking at radiating in all directions. So what's going to happen here is a directional antenna is going to be stronger signal every time, but it has to be applied and focused correctly. So here we can see the antenna radiation that's moving in two polar opposite directions, but it's not spreading, you know, this entire sphere. It's very focused, just like a lighting instrument, and you need to focus your transmitter and your receiver together, and you're going to get much better output there. And then the last one here is a completely focused outdoor antenna, which you can see is very directionally strong in one direction only. And of course, this is for like beaming across city blocks and that type of thing. So here are some common examples of transmitters and receivers that you could see on set. Like I was talking about, there's the Rat Pack, Centena, and AKS, and a lot of us in the industry are familiar with these now as kind of like a standard that people use. Wireless Solutions, WDMX, has a full range of gear. Here's the black box, which is a transmitter and receiver. Also their rack mountable Pro box here. Then we have the RC4 systems, which I believe were developed, you know, long ago to do like Broadway props or like lanterns on like Phantom of the Opera. I hope I'm not misquoting on that, but it is for like flying scenery and in lampposts and that type of thing. Then you have, you know, PCB-based things that can actually be put into flashlights and props like that, or little hand carriage lanterns. We have the Lumen Radio, CRMX type of wireless, which is what you're natively going to find in our Sky panels and Kino Flows, and that seemed to be the industry standard there as far as the film gear stuff. Is this Lumen Radio CRMX is most widely, and that's with the ARRI Skylink, the one they just came out with. ARRI City Theatrical. This is what I was talking about on the newest thing out is the City Theatrical Multiverse. So take some time to check it out, look it up sometime, and see what you think about it. But this is the one that can operate on that tri-band, that 900 megahertz range. And just know that you need to you need to understand and read all your manuals to understand all the aspects of control and limits to the amount of gear on a system or environment. And then here's just what your basic interface looks like. Transmitters can interface with console outputs directly, or in optis, or in data processors or nodes, or via an Ethernet protocol like ArtNet. And some, these days, some lighting fixtures actually have built-in receivers, like we talked about, like the Sky Panel 360 and that sort of thing. And here is just a tiny but dark picture of a small rack that I built to use on location. And this was my board for the location shoots for Empire. So I did have this Hedgehog console. There was 2 universes of wireless being broadcast always through this WDMX black box. One was for the shooting package, and one was for the Astera LED 2 package. And it was, and basically these things all just run together on an unmanaged switch, and that makes the network work there. Cool. So that was a really brief, like wireless is a thing you can really go down the rabbit hole on. That was a pretty brief description. So do we have any questions yet or anything, Dominic?
No, looks like we can move on here.
Okay, perfect.
So let's talk a little bit about the patch and how these fixtures fit into the universes we've been talking about. We'll talk about some common practices and how we decide on fixture modes and how we decide on channel numbers and a lot of other stuff here.
Yeah, and the following examples coming up are how we controlled our shooting package on Empire. And so that concept thing, we want to revisit thinking conceptually and understanding that all the fixtures needed to function on multiple show files on different consoles in different locations, both on the stage and on the road. So like, how do we craft that idea? These patch sheets were handed off to the electricians for the truck load in off-site, and I was actually not around while they were doing this. So that's why this paperwork was introduced.
So let's talk a little bit about the purpose of why we patch. A one-to-one patch where the channels and addresses match up exactly is possible to an extent, but we want to make our jobs as programmers as easiest as possible. We want to make the gaffers' jobs easier. So we typically divide lights into series where 100s, like 101, 102, 103, 104, might represent one kind of fixture. 200s, perhaps a second kind of fixture, and so on. So in this particular patch here, starting at the top, we can see Jared assigned 2101 through 2110 as all sky panels, 2111 through 2116 is all rush pars, and 2121 through 2126 is all keynotes. So we're getting in a series here. So whenever Jared thinks 210 something, he knows he's dealing with the sky panel. Going on to the next slide here, note in this particular patch that Jared goes up to address 498 before he breaks into a new universe. I always find it helpful to maintain a little bit of breathing room just in case you need to add some sort of fixture to a universe or in a bind. We know we have the ability to output 512 slots, parameters, addresses on a universe, but I don't really like filling it up all the way, especially if we need to maintain a little bit of flexibility. Perhaps you don't have a node open with open outputs on the set, so you need to use some kind of universe you have available there. Perhaps you are limited by the gear that made or didn't make its way to the location. I typically like to keep around 20 or so addresses free, and again, this is a judgment call. You'll figure out if you like to fill it up to the brim or perhaps, leave 50 slots open in a universe. It's one of those judgment calls you'll get used to. So in this patch, we can also see fixture addresses, of course, and what mode they're in and what universe they belong to, depending on the console he's using that data control, and what type of signal they're supposed to get. So let's go in a little bit closer here so we can all see it. So in this example, we can see that the S60s are in a 20 channel mode there, mode 6. If Jared is using his ETC board, they get Universe 8. Or if he is using his hog, they are fed Universe 3 through DP11 or Data Processor 11. And each of these fixtures, he has a note there on the right, they should come with an AKS transmitter for wireless control. When deciding on what mode to place your fixture in, keep in mind that you may need to change the mode to enable or unlock additional features. For the S6PCs I had on Next, I also found mode 6 to be very forgiving in case we wish to change to an FX mode or an 8-bit pixel mapping mode. So definitely something to take into consideration. You don't want to start out with a very low parameter count for these advanced fixtures like a sky panel. Talk with your gaffer, figure out what they might potentially need them for, and decide on a happy medium, because we know those sky panels can take up a lot of parameters if we put them in their biggest mode. Make sure to research your fixtures and talk with your gaffer about the goals for them. Using this 9-channel mode that Jared has for his rush pars here enables their strobe parameter, and that's something that Empire likely needed. However, if you won't ever need certain parameters, perhaps it's a show that doesn't need any kind of strobing ever, perhaps a more simple mode would be the way to go. So you can save on your parameters there. So some fixtures have settings that will not be adjustable simply by their mode. And here Jared makes sure to notate what he wants on his keynotes, which is this 16-bit linear setting. These settings may not be adjustable when you change the mode in a fixture, and they might be an entirely different menu tree. So that's something you're not going to be able to change at the console necessarily. Might have to go into the actual back of the fixture.
Right. And as Dominic mentioned on the last slide, this is actually a complex discussion to have with your gaffer, and sometimes that gaffer with the director of photography as well. So when we were speaking about using these LED tubes that are popular now, the Astera tubes, we all had to agree that we would be fine with only 4 pixels of control for each of the tubes. So noting that we would have to run them on the app or take time to readdress them and remode them if we needed to do, wild full 16 pixel effects from them. So another little tip here, when you're getting into it, maybe a little more advanced, but certainly put in your toolbox for later. There's no rule to say you can't have a dummy set of fixtures with expanded attributes already patched into your show file and lying in wait, ready to go to just be switched over. So as soon as you change the address and mode on that particular fixture, you've got a channel dedicated to bring that up already. Often, maybe Dominic too, often we'll patch like the sky panel in an effects mode if we're gonna do like a specific lightning or some sort of thing like that. I already have, 3 or so sky panels patched to lightning mode. So I don't have to worry about creating that on the fly. So here we're talking a little about these Astera tubes, and like we mentioned, we want to get into the digital representation on our consoles. So here, what we're looking at is a graphical representation of the 32 Astera tubes and their groups, which are the headings here, aka AX1, kit number 1, etc., and their pixels. So the concept here is, for each of these tubes, I wrote in 5 subgroups to control the tubes. So all pixel groups, the groups I made were all pixels, pixels 1 and 2, pixels 2 and 3, pixels 3 and 4, and pixels 1 and 4. So in that way, I had all those groups for each of these 32 fixtures, right? So I can manipulate anything like really quickly. And you'll see later a different idea with the same results on the hog system. This one's called a per fixture magic sheet, and I would recall these using snapshots in the ETC EOS or Ion console. And basically that, let me just point out over here. So how this digital magic sheet here is set up, this heading here of what the kit was is actually a group. So if I clicked on that, I would actually control my first 8 tubes, 2001 through 2008, because they come in kits of 8. And then you can see here, this is my group 2001, which controls pixel tube 2001. And so when I select group 2001, that would select each of these 4 pixels on that tube. And so I can easily see, I don't have to be on set to know what this tube is doing, right? I can see that it's in a red color palette. I can see that all 4 of these pixels are on and their level is at full. And then so same thing, if we look at tube 2002 here, I can see that only pixels 1 and 2 are on. Same with 2003, 2 and 3, 3 and 4, and 1 and 4 down the line. So that shows you how, again, now we're taking that concept we use when creating lighting plots and set maps, and now we're translating it to digitally control the lighting instruments themselves. This is what I'm calling, a group magic sheet, and it has also the aforementioned subgroups. The other thing to note here is this is just a secondary way of looking at that same tube array of the 32 tubes, but I included a mini channel pixel block that reads the same as the fixture magic sheet. So if you see here, this is the same information I was representing in the last slide, but it's not in that expanded way. This is my group magic sheet. So here you can see I have pixels 1 through 4 on, pixels 1 and 2, 2 and 3, 3 and 4, 1 and 4, just like on the previous slide. So again, I don't need to be on set looking at it to know what these tubes are doing, which is really helpful when dealing with a multi-pixel fixture. Yeah, exactly. And then again, I'm using, you'll see the little camera up here. This is a concept on the EOS line of software called a snapshot. And we'll talk about this a little bit later with the other consoles. Snapshot is a way to quickly record the views of your screens so you can change which screen you have up on your console at any given time. And we talked about having various touch screens and this and that. There can be up to 5 or 6 screens if you're really rocking a big setup. And then you can record snapshots of what all those layouts look like and quickly recall them from your lighting console. Cool. Any questions yet, Don, or we're still cooking along?
Still looking good.
Okay, very good.
So let's look at some patch lists again. The previous one Jared and I showed, I believe that was a Lightright one.
That was just an Excel document.
Nice. Cool. So let's look at some printouts. You can actually get the console to export. So here's an example of an EOS show file patch printout. Every console has their version of a show report. EOS tells you the number of fixtures patched at the top, their assigned channel and addresses down below, what mode and bit they're in. And note we don't see a dimmer curve at the freeze files. Again, this is controlled on the fixture itself. Let's go ahead and go to another ETC printout, another example. You'll see these a lot. So sometimes you're going to come to a venue that might be a little bit less organized. And here's a patch from a downtown Chicago balcony style venue. Not a ton of info, but there's enough to where you should be able to make everything work on your own console if you're bringing your own console into this outside venue. So we see the names of fixtures, the make, the model. The mode 12 channel isn't really descriptive, but we can probably discern from that we need to pick some kind of profile for the MH2 on our board that controls 12 channels. And of course, we see a universe and a starting address there. So be aware that you're going to see, perhaps some homemade patches out there, and it's up to you to translate them to be able to control the fixtures and set up your console. Let's take a look at an MA2 patch export. Again, fairly similar to the export from all consoles. A couple extra columns for extra info if you wanted to put that in there. And quick note here, MA has both fixture ID and channel ID in there. You might know from EOS, it's typically just called straight channel. MA offers you the ability to give 2 IDs to a fixture. Personally, I typically stick just with fixture or channel, and I don't use both. And you can see in this patch here, I don't even have the channel ID column filled in at all. But if you wanted to be fancy and give a lighting instrument both a fixture ID and a channel ID, you could. Let's take a look at another kind of homemade patch here from another venue in Chicago. There's enough info to get by. We can see some redlining kind of going on there where they made some changes. Just another example of the paperwork you might see, and it's up to you to be able to translate that paperwork. Let's take a look at another MA2 patch. So make sure you're reading all the paperwork when you receive these patches. A critical detail here I'd like to point out is the clay-pakey mythos vector profile. Note at the end it says lamp on. Several moving head fixtures that have an actual lamp in them that needs to get lamped on. They'll usually have two profiles, one with lamp on and one with lamp off. So this is something to take into consideration if you're going to a venue and you want to be nice to that venue. Say we're going to shoot at this particular place and we're told, hey, we're not going to use these mythos at all day. Well, as a good lighting programmer or dimmer board op, we should take the time to turn those lamps off. That way they're not burning inside the fixture all day.
Okay, so if there's no questions on the patch section, we're going to start to look at how does it look on the actual screen of these lighting consoles. We started to look a little bit at the magic sheet on the EOS, but just stressing, I don't want to overcomplicate it, but just the core understanding that the patch is how we're actually controlling our lighting fixtures through the lighting console, which is taking that start address we know from our DMX 101 class, the start address that we set on that particular fixture, if it's our sky panel or whatever, it's taking that start address, it's the console itself is telling it a mode or a library or a profile to be in. And then we are giving it a number of our choice, which is the channel, which is how we actually physically bring that light up on the console. So I just wanted to make that clear if anything was not clear about patching. So we're going to take a look at how these patches are represented and manipulated on the screen. Again, our three here, we're going to glance at EOS, HOG, and MA. Understand that now we're getting into the deeper stuff. There's a lot of rabbit holes to go down. You can spend hours and hours on each of these subjects, but this is an overview for understanding. And many of these manufacturers, I know those three definitely have YouTube channels and all sorts of great programming acumen sites to really get your knowledge base up, and you should definitely check all those out when you can.
We'll be providing an email with a pretty exhaustive list of YouTubes and ACT lighting seminars and all sorts of other places where you can actually download this software to your computer and start to get the programming.
Yeah, absolutely. Thanks. Okay, here we go. So here is the basic patch screen for an ETC EOS system. And the point we can make too about talking about EOS, Ion, Geo, all the line of like an ETC console, MA2s, MA3s, high-end systems, hedgehogs, full bores, roadhogs, what have you. Each of their consoles runs the same software on each of their lines, right? So your show files, if you create on one console, they are usable by another console. It looks like we had a question pop up, right?
They were just saying thank you for the info.
Oh, okay, very good. Sorry. But anyway, so that point is to make that there. So like I said, basic patch screen for the ETC EOS here. We're going to zoom in a little, but we're going to look at each section. So here we have that, we said starting address, like we spoke about, patch to a channel here, which is that physical channel we bring up on lighting console. So when I bring up channel 1 on this lighting console, what the fixture that begins at universe 2 address 1 and is labeled we see here that's like a sockopec, so it's labeled AA. So that's the fixture that's going to come up, or that circuit that is that light is plugged into. That's the one that's going to come up there. So the label, I want to stress, as a programmer, labeling everything you do is one of the most important things you can do as a programmer. We talk about labeling cues and labeling patch and labeling all this stuff. Labeling, just how it was so important on the lighting plots and magic sheets. If you don't label something when you create it, you're going to go back and look at a bunch of blanks of things you don't even know what they are anymore. Like if I build 20 effects in a session and I don't label any of them, I don't know what I've got, right? So always label everything. All consoles give you the ability to label most everything. The interface here, because this was created on an offline software, it's not really showing it. But this is here where it would tell you, you know, I'm using a DMX regular interface, or I have SACN or ArtNet or that type of thing. And then output would be showing you the typically the hexadecimal value, which we'll get into a little bit later, but you've gotten into in your DMX class, you know that the actual percentage range of 0 to 100% is represented by the hexadecimal value of 0 to 255. So if my channel 1 was full here, my output would say 255, if that all makes sense. And then we're going to talk about our patch block down here, and know that this big block here that I'm circling represents all the universes you could be using, which that's a lot of universes, right? 50 universes. And then over here we see the type, which matches up here. This is just a regular dimmer channel. If it was a sky panel, it would say sky panel here. The label, so on and so forth. So this is actually just reaffirming what is in this box up here. So let's punch in a little closer so we can see the syntax here. So this little patch block, this is how you view what is patched and what's not on a given universe. So here we can see we are taking a snapshot look at universe 1. And all these grayed out numbers, you see address 1 through 512, all these grayed out numbers are the addresses that have been patched to a given fixture in this show file we have. So we can see when there's a black background here, we are not, we have open addresses which we can use to patch new fixtures in. So if I need to add a new fixture that was like 50 addresses wide, I could start that patch at universe 1, address 337, and I would have all of this room to patch new fixtures. An important thing to note about the ETC EOS software is this little highlighted button here. It's everybody's best friend. If you click this, if you hadn't turned this on, what you would be seeing here, if I looked at universe 2, you would see the start address of universe 2 would be 513, and you would see, instead of 512 down here, you'd see 1024. So it's like older guys who used to program the old consoles before this sort of universe address concept came into play. You know, we would have to deal with like patch 2376, you know, instead of just like universe 4, you know, address 46 or something like that. So it's much more manageable now, is the point to make. Okay, moving on. So here what we're looking at is a profile, or a we can call it a number of different things. The board calls it a profile, a library, a protocol. In user manuals, like we talked about, knowing our fixtures, reading our user manuals, and seeing our DMX protocols. So this is a DMX protocol we can see for it's a sky panel S60, which is a fixture a lot of us use on set, and it's set to be in mode 6, which mode 6 represents color temperature correction and RGBW color mixing, and a 16-bit resolution per function. We'll explain that in a little bit. But this is basically, this tells you the entire range of things that fixture can do and how it's addressed in the lighting console, and how the lighting console figures out how to process the data going to the light. So we can see that our dimmer channel here, we have is mapped to both address 1 and 2, because 16-bit resolution basically means it's just taking up 2 address slots instead of 1 to control that fixture, making for a smoother fade. But we can see that the most important concept to state here is that when you are using a fixture, an intelligent fixture like a sky panel or a moving light or anything like that, that the profile of the fixture that's set on the fixture is the one you want the board to have that library protocol in, and that's the mode you need to be using and calling into your patch. That way, if we're in mode 6 on the light, we're in mode 6 in the board, and every attribute parameter lines up so we can control it accurately, if that all makes sense. Okay, moving on. So here, sticking with the EOS, now we're looking at the representation of that sky panel on the EOS itself. So we can see here, we're looking at the fixtures mode. We can see here that our sky panel S60 mode 6 is highlighted. And then what I'm looking at over here is the digital match to that protocol that was on the previous slide. So we can see here that my intensity channel for that sky panel is a 16-bit, right? 16-bit. I know it's kind of small for your screens. I'm sorry about that. But it is mapped to address 1 and 2 in this profile. So we know that that everything is lined up like was in the previous protocol from the manual. And that's how the console itself thinks about things. A couple other things to mention about intelligent fixtures like this, and like these days, if we're not just plugging in an incandescent light, chances are it's some sort of LED intelligent light with multiple parameters, be it your Kino flows or your sky panels or your any color mixing, moving, automated light, that type of thing. So 8-bit, like I said, versus 16-bit parameters, 8-bit only takes up 1 address slot in your universe, 16-bit takes up 2 address slots. And so when, you know, a lot of us agree with the gaffer and DP that we set these fixtures into 16-bit mode, that way they provide the smoothest curve when you're executing a cue live on camera, would be the reason to have everything in 16-bit mode. I want to talk real quick about hard and virtual parameters. And parameters is what we're calling these things like intensity, color temperature, color crossfade, even red, green, blue, white, cooling fan. These are all parameters of the lighting fixture. So a hard parameter is these things that have hard address values. So like the intensity and color temperature correction and that sort of thing. Now a virtual parameter is something we see down here: hue, saturation, and brightness. And if you remember back, if you were here yesterday, I talked about an L7 Fresnel that was using a hue, saturation, intensity color mixing structure. So what modern lighting consoles do is they create these virtual attributes, right? For you to be able to have several different ways to mix color or do something like that. So here, even though we're not taking up a hard address slot in the patch, we're creating a fixture that can mix with both hue and saturation and brightness / intensity. So that is a virtual parameter that the lighting console creates for you that you can use when using this fixture. Cool. Any questions on the EOS patch there?
No, we did have Mr. David Fox from ETC comment with some courses that ETC has available, and those are in the answer portion of the Q&A.
Super. Okay, great. All right, let's take a look at the patch sheet from the Hog 4. So this is the basic patch screen of the Hog 4. You're going to see a lot of the same concepts are represented in these different consoles, right? So that's the thing, like we said, there's lots of tools in the toolkit. You as an end user get to pick, or in conjunction with your boss or however you want to think about it, but pick the console that's right for you, you know, that feels the best. And it's just like buying a car or a phone or, you know, anything else like console or renting or whatever. So the sections we have here, we're looking at, this is a little smaller to read, but here we have that, talking about the shooting package, we're looking at our sky panels again. So we have channel 2101 highlighted. We can see that it's an S60C, and this is actually note column. That's a user-defined column, so you can write whatever notes you need to into that column. We can see how it's patched here. We talked about system expansion. This is patched into DP 8000 number 11. So that's data processor 11. So perhaps we're using 10 other data processors, but we don't have to. It's just a certain processor that it's plugged into. We can see that in processor 11, this is patched into universe 3, and it starts at address 1. So, and the protocol, like we mentioned here, is just DMX right now. So, and we can see that the intensity here is 100%, so it's live in this particular show file right now. So really, this is like a match to the EOS, and it will be matched to the MA. You know, they each have their different idiosyncrasies, but the information is pretty standard. On Hog, other things you can see here, you can quickly jump around to each of your fixture group types. So if I were to hit this Cineo Maverick, that would jump to, it would focus in basically on this section here where my Cineo Maverick is patched. So that's a quick way to navigate through your patch sheet on Hog, which is a nice device. So you can note that the syntax and similarities to EOS there. The other things up here, all sorts of stuff for Hog itself. This is how you add new fixtures, adding to your patch. You go into add fixtures. And I know for sure, well, on the Hog and the MA, you can actually then just type in the fixture you're looking for, and it will scan the library of thousands and thousands and thousands of different lights to find the light you're looking for and want to patch. And, you know, kudos to all the manufacturers who keep these libraries up to date. I mean, there's just, I mean, you could think there's so many lighting instruments out there, and they keep these profiles pretty current for everything. Some other things here, we're going to talk about the Hog view by DP, which is a cool feature on the next slide. And here you can edit your fixtures. You can actually build your own fixtures, and that's something we're not going to really get into today. But I did mention that you could like merge two fixtures together and build your own. If like one was just a static wash light and one was the articulating arm, you could build a moving light of your own and use it. So let's look at the view by DP on the Hog. So when I view by DP, this is kind of like viewing that EOS patch box, right? So I can see that on my DP 8000 number 11 over here, network ID 11, that these are all the things patched into Universe 3. So it's a quick look at the blocks of Universe that are patched. And I can see that my good old Sky Panel 2101 is sitting here on Universe 3 at address 1. So this is another way to look quickly for open channels. I can see down here at address 405 that I have 48 free channels in which to patch any fixtures. And now getting back to that concept that you know, we're substitute board ops or we're taking over for a day. Like a lot of times gaffers will add, say, pull some LED ribbon from the cart and put a controller in, and we need to have some ribbon in here. So if I need to wirelessly control that ribbon, I know that's my wireless universe here, and that I have my transmitter on that, and we're going to use a receiver for it. I would say, hey, I have all this room here to patch that ribbon at starting at address 405, and I know I'm good to go. I can just bring that fixture in, and it will have a profile that will control the hybrid aspect of that ribbon or the color mixing aspect of that ribbon or whatever. So that's the most important thing to note on this screen. Another thing when patching Hog 4, this is just another thing that is a pop-up when you're patching. This is another way to do it. This is actually, you can physically tap this and tap that. And then if I said even patch next on this universe, it would patch the fixture you were doing to the next open address, which would be 449. So this is another way, you know, just to select universes and patches real quickly. Because a lot of times we think about the Hog and the MA more as the rock and roll boards, you know, but it's not necessarily the case. But these modern, I'll just call them the modern lighting consoles, right? The modern software is set up to just patch, you know, thousands of lights and thousands of pixels of lights, like very quickly, you know, and accurately. So just know that as we go through here, patch is a really important thing to master on your console. And if you're beginning and starting out, you really want to be comfortable with patching instruments for sure. The last little thing we'll look at on the hog right now is it's a little bit different when viewing. This is now we're viewing the protocol type of page. Like we looked at the Sky Panel protocol from the manual, and we looked at the Sky Panel protocol on the EOS. Now we're looking at it on the hog. It's a little bit different, but here you can see sort of the same thing represented. Here's again our intensity channel for that, our favorite Sky Panel 2101 that we all know now. And it's just a different way of reading the protocol. You can take a minute to do it. You know, it's nothing specific, but here I can pick all the fixtures that are in my show and look at the protocol they're representing. And here it shows me, you know, just how many of those fixtures there are. And I'm able to jump around real quick and look at that. The point I wanted to make out here was you can also look at this stuff in the edit fixtures portion of the hog selection. You can also sort by, there's something here, when you click the sort by function button. Now this is an interesting button for hog. Because what it is why it's handy is what it'll do now is it, instead of viewing all my sky panels as an individual sky panel, it will take all my sky panel intensities and put them together. So I'll see 2101 through 2110, and I'll see all of the intensities together. So if for some reason I need to change a default attribute of that light, or say it was a moving light with pan and tilt, I could have all the pans in one place, and I could just, you know, select them all, right click them, and change their default value. And I've done that quickly because I sorted by function. So that's just a little tidbit about working with hog. So any questions about this hog patch or screens yet?
If anybody has any questions or even comments, just go to town. We're here.
All right, cool. And Dominic's going to talk a little bit about the MA now.
Yeah. So we've seen two consoles now, and we'll breeze through MA because it's fairly similar, but it does have its differences from EOS and Hog 4. So you have to go to a setup portion and you access your patch in the upper left corner, patch and fixture schedule. And in MA2, you create a layer first and then add fixtures to that layer on the next slide there. You might divide the layers between stages or perhaps between fixture types, as I've done here, perhaps between hang locations. There's all sorts of decisions to make here. Operationally, layers don't have a lot of effect unless you're doing some advanced work like macros or cloning or modifying patches, but it's just another, think of it as another way to keep your patch clean. You can also see here that we have the option to give two operational selections for these lighting instruments that we talked about earlier, fixture and channel. And here we see that they are both the same. And in my programming, I typically just use the same number for ease of use. However, again, you might have a unique use for this in your programming. So we'll take a look, view at the DMX list, and there's several ways in MA2 to view your DMX patch and universe setup. We'll take a quick look at the fixture library here. Again, we're looking at the an RE Sky panel. Here I have a 120 selected, but again, we're in P6 mode. And this is how MA goes over the parameters for that fixtures. We can also see some notes at the bottom here, kind of a little handy thing to look at if you're wondering where you might set that in the actual fixture. It gives you a little note about it there too. Also gives you a little revisions that you can kind of see at the bottom too, just a different way of displaying the same information. So here's another way to view patch and modify your fixture patches. And don't be intimidated by the number of ways you can view the MA2 patch. You don't have to utilize all of them to achieve your programming goals. As long as you can figure out one way in all of these consoles to get your patch proper, it doesn't mean you have to learn every single way.
Okay, now we're jumping between all these consoles. we're taking a look now at what that, when we looked at the full patch sheet of the Empire patch sheet of the shooting package, this is now what it is represented in my group directory on a hog, in a hog environment. So the ease of control sometimes varies console to console, though the fixtures and patch are the same. So it's, again, how do I access and accurately manipulate my my fixtures on different interfaces. So here we talked about groups, obviously one of the most important concepts we've been discussing for the past 2 days. So you can see that this is and this can actually be viewed on a very small screen and all fit. So all these, to know, as programmers and ops, we set up our consoles in a specific way. There's a lot of user definability. You define how big you want your blocks and what they're labeled and all of this, but this is like kind of advanced stuff and back for, when you're setting up the console initially for the show. But here again, just stressing that groups thing, like we're just kind of hammering on the sky panels because that's the first ones in line, So here we can see my fixtures, which are 2101 through 2110. And these are all my different sky panels I have on my shooting package. So here's the 60s, and then the 120s, and then the 360s. And so you see I've built a group here that would control, group 305 would control all the sky panels in this row. And then this particular group 306 would just control all 6 of these S60s. And this group, these two 120s, and so on and so forth. So you can see that we have this group page show the entire shooting package, so I can access any fixture on our cart from this one screen. And as soon as I tap on one of these fixtures, it will bring the attributes of control into that lighting console, whether it be EOS, HOG, or MA, or whatever. So we can see as soon as I've tapped on 2101 here, my first bank of parameters has popped up, which is intensity and sub-intensity. And you have to know, you have to be smart about the differences consoles can take with instruments. So for instance, those who might have seen Sky Panel on an ETC EOS, you would know this channel, the sub-intensity one, actually is color crossfade. But on a HOG, the way they built their library, it's called sub-intensity 1. So if you want to be in RGBW color mix mode, you would need to put sub-intensity 1 to full, just like you would put color crossfade to full on both the EOS and MA, I believe. So that's something to note. There are differences between consoles. And it's not a rule that each of the different console manufacturers have to be on the same page with each other, right? So that's one of those things you deal with, as a programmer. Moving on, we see my group directory for the Astera tubes that we're talking about, the 32 Astera tubes, but this is actually broken down, I did into groups of 16. And so for better or for worse, or whatever reason in my head, on when I'm using a HOG system or an MA, I like to use a dotted fixture number for the Astera tube. So if I were able to call it pixel 1 on tube 2001, I would just say 2001.1, and I would get that first pixel. But here you can see, just like on the EOS Magic Sheet, this is kind of like a mimic of that, but I built it in a group directory. So here we see this is pixel tube 2001 and each of the pixels that is on that tube. So here again, it's about quickly grabbing control of that stuff. Now, I talked about snapshots a little bit with EOS as a way to record your screens and move around quickly. So here in HOG, what we have is called views, and it's the same as MA views and EOS snapshots. So if I record a view in HOG, and you can have up to, I don't know, 100, and on MA, I think it's like unlimited, like 999 pages of them. I don't know. Dominic will tell me. But you're able to record all these different screen layouts so you can quickly move around to what you need to get to. So in this instance, I have a group view for this particular group directory. I probably call it tubes or something like that. And I can press that view and I pop right into this. So this is, like I said, is one page of normal AX1 tubes, and the protocol I'm using is the same on any of these consoles I would be using. beforehand, I actually, you build a custom protocol and you can use it on each of these consoles as well. This is the second page with the Titan tubes, which are the brighter of those particular tubes. But same layout, same idea. I've got a group here for all Astera, so that would grab all 16 of these tubes, and that sort of thing. So that is, you kind of get the idea of where we're going with these different things. And moving on then.
Yeah. So we've talked a lot about customizability and some differences between the consoles. Let's take a step back from that customizability. If you want to learn these abilities, again, there's videos online for you to do that, or I have quite a lot of free time now, and if you don't like learning online, just hit me up and I can help. So let's talk now about what these consoles actually have in common. So all consoles do have a programmer section where you control channel values through keypad. It's universal across. So that's, when you're typing in channel 30 at 50%, all consoles have that. All consoles have those encoder wheels at the top that allow you to dial in a parameter. Perhaps you're trying to get that intensity just right. All consoles have palettes or pools, and that's where you store data or presets into these palettes or pools for a quick recall. For example, you can have a pool for 3000K, and if you were to click, say, your Titan Tube group and click that 3000K group, it would turn 3000K. So palettes and pools definitely provide a really strong method of storing values. All consoles have queue lists. This is ideally where data gets recorded or stored after you finish dialing your values in the programmer with the encoder wheel or with the palettes. And all consoles do have a master. You're probably familiar with the Grandmaster. You can also create masters for a limited section of fixtures, and these masters can operate to increase a value or decrease a value, kind of set a limiter, and make several other adjustments. And of course, all consoles have a patch. Let's talk a little bit about universal parameters that are common among all the consoles. So we just talked about that hypothetical channel 20 going to 50%. That would be an intensity parameter. And most consoles have relatively similar descriptions for these parameters. So in EOS, it's called intensity. In HOG, it's called intensity. And in MA, it's called intensity. We also have some parameters for moving lights. So moving light moving around, that would be a position, and that is common between EOS, HOG, and MA as well. We also note focus here. So that could be your zoom or how sharp a fixture is currently focusing. And we also have color parameters, of course. That's common amongst all three consoles. And another one is beam. So in certain consoles that could define gobo or other types of parameters. Some consoles have the strobe function under beam, and these four are the most common. You'll also see in some more complex situations parameters like control. That would be where you find fan controls, or if you're, again, working with a fixture like the clay picky mythos, that's where you would go to turn the lamp off or on. There's parameters like video, which we'll talk a little bit at the end, that might concern pixel mapping. And there is also on MA2, there's a parameter called shaper, and that's with some of the more advanced fixtures, like the high-end Sola frame. They have some really cool shapers in there. And we have a question from Daniel. Do either of us know of a cheat sheet that has the verbiage or language that's used for each manufacturer console nomenclature? Or is it the same thing across all three for ETC, HOG, and MA? So I could try. I think we could probably find some good cheat sheets out there. The language used to control can be very similar, but it's not always the same. For example, setting a level in Grand MA could be channel 20 at 20% please. Grand MA has a please button instead of an enter.
Right. Um, Another place you could probably look for this is, and I think we may have links with some of this stuff, but when we talked about a little bit about shortcuts, those will have console specific keys in those particular shortcuts with the sort of definition. But again, like I'm going to say, I don't know. Yeah, Dom can probably find them. I don't know offhand what exactly that is without going to like the glossary of the manual. But there are, I'm sure, like key layouts and that sort of thing, which you can look at, zoomed in. We're actually going to look at the key layouts on the consoles coming up in a few slides. It'll be hard to like memorize them all or that sort of thing. But that will
You'll
kind of
eventually memorize them for sure.
yeah. It'll become sort of secondhand as you get into it.
Yeah. So MA definitely has a pretty strong cheat sheet, and I'm sure there's some actual custom MA cheat sheets out there that people have built. One process that Jared definitely talked about in depth was the importance of labeling everything. Well, on the MA keyboard, there isn't actually a label key. To get to label, you triple hit assign. So there's a lot of cheat sheets out there that mention, oh, if you hit this button this many times, this command will pop up. So we'll definitely look up some cheat sheets and provide those in our email.
Yeah, and just like our computers or laptops, there's often something that functions as a shift key or a control key. Like on the Hog, there's a key with the little flying pig on it, and that functions as a shift key and a selection key for different things, as well as, like Dominic mentioned, triple clicking and double clicking is also something you have to get used to. Because, for example, on an EOS, like if I click color palette once, and in my command line, I'm doing it like I'm assigning that color palette then to a fixture. If I double click color palette, it's going to open my list of color palettes that I have built in that show file. So there is a lot of double and triple clicking and stuff. And so, yeah, we'll work to get you some shortcuts on that sort of thing.
Yeah, I hope that answered that question. And if not, feel free to ask it again with the different wording, but I think we got that.
Cool. Okay. So now, as we just kind of talked about, I want to throw in a bonus point. When we're talking about these universal parameters, make sure, here's your homework, look up parameter masking, right? Because all the consoles use this concept, and it's something we do. And a very basic example of this is, say, I'm controlling an intelligent light, right? But I want to mask intensity, or I only want to record the attributes of the intensities that are there. So I can actually mask out all the other attributes, or only grab the mask of the certain attribute I want. So in this case, intensity, and record that into a certain setting or queue. So that's just a little homework. Look up masking. All right, who's excited now, right? We're finally going to talk about the programmer interface on these lighting consoles. So we hammered home the why we do things, and now we're going to look at a little bit of the how. But again, this isn't really the button pushing programming class. This is kind of the idea behind everything. And Dominic mentioned a lot of other sources we'll be providing and that manufacturers provide for that once you step into actually programming the console. So let's check out a couple desks and what they look like. So here we have an Ion XE control surface. And we can see the sort of the button layouts and attributes of each console that are similar. Here, we have our encoder wheels, like we talked about. We have our masters, our go and stop back button, our intensity wheel, which is a lot of consoles have wheels for things. We call it put it on the wheel, means like selecting a channel and then rolling it up via the wheel. This particular thing here can be assigned to be the rate wheel of like a certain effect and that sort of thing. We see like our numerical keypad, which is pretty consistent on all consoles. That's the way, we set, channel 1 at 2020, enter. That's a 20%. A lot of consoles have the syntax of when you're wanting to do something at 20%, you can actually just say at 2, and it just knows you want to go in the 10 increments. So if I put something at 2, it'll go to 20. But if I want to actually be at 2%, I'll put it at 0, 2. And a lot of these consoles have that concept to them. But yeah, the numeric keypad, the enter functions. We have the record, the cue. Here's our palettes. And we'll see that these things are sort of represented in the same way on all the consoles. Something most all consoles have too is a live and a blind mode, and live is what we're doing live out of the programmer. We see it represented on stage when we're doing something. Blind is a way to look through all your cueing and programming and a lot of different things, your color palettes, without actually affecting anything on stage. So that's an important thing to note. A mistake that happens a lot is thinking you're doing something live when you're in blind or blind when you're in live. So that is an important thing as a programmer to note, to make sure that when you want to actually be outputting to the stage, you are clicked here into this live mode, and all the consoles have something like this. So here is the digital virtual representation of that EOS console, which when you download their Nomad software for your computer, this is what you're going to be looking at. And to know, with all these offline softwares, there's virtual representations of each of these type of consoles. So there's tons of buttons and soft keys, and you need to familiarize yourself with the big ones, right? So we're talking here again about the number keys, the at key, AT, the enter key, the out key, which is a out, or I know on MA, if you want to put something at full, you can double click at or dot dot period, and it takes it out. So those are the things you want to know. Recording, updating, time, palette, on EOS Sneak, which is a way to, if you've set a level on an instrument and you want it to return to the level it was, you can use Sneak in a given amount of time, and that light will fade back down to its value that it was previously at. How to jump between cues, go to cue, or recall from. Recall from is a really cool thing on the EOS, which basically you can use recall from to take all the attributes of one light and copy them to another light. And there are ways to do this on Hog and MA as well. But so for instance, if I had a blue, my infamous sky panel, if it was blue and strobing, I could hit, sky panel 2102, recall from 2101. And now I've got 2102 that's blue and strobing at the same rate as one. So that's a quick way to do programming as well. We talked a little bit about live and blind. We'll talk about recording cues a little bit. There's something we're definitely not going to dive into here, but the idea of cue tracking versus cue only. And that just means if you track, if you record to track, that means the values you put into your console are going to move through all the cues where they don't find something blocking them. If you're doing cue only, it means you're only recording into a cue that per one particular cue, and you're not tracking any information through the rest of your cue list. So it gets into a lot of things, right? But as a substitute or just someone backing someone up, the majority of the keys and functions you're not really going to be concerned with. I don't think, So, and then like we mentioned, double tapping and triple tapping can cause things to occur. But like a keystroke on EOS to clear your command line would be shift and then clear. So there's so many, it's tough to say, but there's like thousands of combinations to keys, right? So that's why it's a tough gig to learn all these different consoles. So cool. So any questions on the EOS framework here? I will mention a couple other things. I'm sorry. If you can see what I'm circling over here is a little camera up here. this is how you're viewing the snapshot that I talked about. So snapshot was that moving around to different screen setups very quickly. Here, when you're on your offline software, this pops up your virtual keypad for queuing in stuff. This little representation of lights here is a magic sheet representation. And so when I click on this, if I have any magic sheets built, like my Asteratubes, for instance, I had my Asteratube group magic sheet, fixture magic sheet. I would click this, all the magic sheets I built would pop up and I'd be able to select one quickly to move. I'm sorry, I had this backwards, I apologize. This is actually the wand over here, the little Harry Potter wand, right? That's the magic sheet button. And then this is called ML controls on EOS, moving light controls. So when I select an intelligent fixture like a sky panel and I click on ML controls, that's going to pop up and show you all the specific attributes of that intelligent lighting fixture. Sorry about that flip-flop.
There was a question about different
Great.
terminology.
Okay.
We'll tackle it, I think, after we show all the control surfaces quickly.
Okay, great. So here we have a full bore Hog 4. Again, a lot of common attributes here. Multiple touch screens. You know, our bank of masters, where we can record cues and assign cue list, our grandmaster over here. This particular console has a trackball for quicker focusing moving lights and that sort of thing. Again, encoder wheels, number keypad, our generic palettes, masks, and keystrokes over here, our little flying pig down here, shift type of key. So here again, you can see these consoles are all very similar in their nature. Here's a digital up close of what that control surface looks like when you're using the Hog PC software, which is their offline version of the console that can actually be brought online with processors to control rigs. So some people build their own Hog PC rigs and use those to control things. But here again, encoder wheels, level wheel, you know, put it on the wheel, the focusing encoder ball over here. We've got our intensity, position, color, and beam, which were those attributes of common attributes, parameters we talked about. So that way, like when I select my 2101 enter sky panel, I click on intensity, I'll see my intensity, main intensity here, and I'll see my sub intensity here. When I click the color, all the ways of different color mixing will be mapped to these encoders up here, and I can spin the encoders and dial those attributes, right? So we start to understand that kind of concept with the way the encoder wheels map. And also on the consoles, if you continue to click through, like if your lighting instrument has 7 different ways to mix color, right? Or your media server or whatever, you'll be able to hit color 6 times and see 7 different encoder maps, right? So that's something to keep in mind as you're doing this stuff too. But we see here the good old record button. You know, a lot of things are represented the same. We already talked about double taps, and we talked about the pig, our little flying guy over here, to be used as a shift key and a modifier key. Hopefully I'm not missing too much there. This is a highlight I'll talk about real quick, is a rock and roll type of function that allows you to, all the fixtures you have, if you select them and highlight is turned on and you hit enter of like a whole group, highlight will take all those fixtures, for instance, like open white and or whatever value you set for the highlight, and you'll be able to quickly hit next or back and just hammer through those fixtures one by one. This is a quick way, like rock and roll people would use to focus and update palettes, focus palettes. You could just highlight the fixture and go to next down the line, and that would be something you can do. Also here on this particular console, and we see it in all the large sized consoles, the flagship consoles of each line, are, you know, user definable buttons. Here, these are populated with color palettes on the Hog command, called command keys here. Populated right now with color palettes, red, green, blue, cyan, magenta, yellow, white, so on and so forth. So there's a lot of user definable surfaces on our consoles as well. Here's Dom to say a little bit about the MA.
Definitely. We'll move through MA pretty quickly here, and then we'll answer Daniel's question. I think this console would provide a good way to talk about how some of the terminology is the same and how some of the terminology is different. So again, seeing items that are the same, we see encoder wheels, we see a number pad. Let's move on to the next slide to see a digital representation here. So again, number pad, encoders at the top. The very top of the screen, you see MA's version of parameters. So dimmer is what MA calls intensity. Position has been the same throughout. Skip gobo and we'll look at color. Color has been the same throughout. If we go back quickly to the hog board, this one right here. So we see intensity, position, and color. And then we see beam. Going back to that MA screen, MA kind of parses out what Hog would call beam into a whole bunch of different sections. So we have gobo, we have beam, and we have focus. So Jared was talking about, oh, the fixture might have a lot of functions and you need to hit that parameter like beam multiple times to see, you know, all 7 or 8. If you were to control that fixture on an MA console, that would be spread between gobo, beam, and focus there. So that's the way that the consoles are different, and that MA just has a couple more added here. We also see shapers at the end there. I believe a shaper and hog might also fall under the beam parameter.
Yeah.
So this is where they're a little bit different, but again, we are talking about universal parameters, and each board can do the same thing. So I hope that answered your question there a little bit better. And here we see a command overlay. So another way that MA will allow you to control via your on PC. Similar buttons, you know, we have the number pad, we have a full, we have a highlight. We have a couple different items. I'd like to mention that the items tend to be grouped the same. So the number grouping, we have a verb grouping in the upper left, and then we have more of a pool grouping in the middle just above it. So MA does try to get their keys of similar function in the same area. And again, you don't have to know all of these buttons, especially if you're just coming to the stage for the day to control. What you're really going to be controlling a lot of is hitting a number key at percent to control the intensity. And then you'll need to know how to bring up a parameter to control color or to select the gobo. Let's go ahead and talk about channel feedback a little bit.
Okay, so with channel feedback, these are some simple screens on the desks that give you tons of info. So again, we're going to talk about what's represented here. Channel values, fixture names, etc. And what's to note here, each color is representative of a source of the info or feedback on a value change. So we can see that. So moving forward, this is that blind window I was talking about. So we were in live here and now we're in blind. I said most consoles have a blind window that allow you to make changes, track levels, and do a variety of other programming tasks without outputting to the actual stage. It's important to note most commands will be executed without a confirmation when working in blind. So as soon as you change something in blind and hit enter, the command is terminated and executed. Here you want to use your channel number color feedback here as well. And the point to make about blind is that, like, for instance, on EOS, when you go back into live in the queue you're in, if you made changes to that particular queue, you need to reload the queue. So if I was in Q1, I made a change in blind, I wanted to update live, I would need to go back into live and go back into that queue, go to Q1. So here's the channel feedback, and we'll click back and forth between the screens. So if it's a red number, that represents a captured value, which means it's that fixture is live, and in the programmer, you've captured it for manipulation live. A blue value here, and we're talking about EEOS line right now. Other consoles have different color combinations, and we won't get too much into those, but we want to show you the concept of what this is, the channel feedback right now. So the bluish cyan here means the value has gone up from the last cue. The green value means the value has gone down from the last cue. Tracking, that thing I mentioned, it's the value of that light is coming from a previous cue and has not changed. So that's the purple tracking value here. The yellow submaster means that that value is being mapped to a submaster right now, and the submaster has ultimate control of that value. It's not being, it's being represented by the level of that submaster as opposed to the level in the lighting cue. And then blocks, we won't get into, but that works along with tracking. When you don't want something to track through, you can block the entire cue or block a certain attribute or block that one light in a cue itself. So here, again, we see the screen. So we have our purple tracking values, our blue going up values, our green going down values. We have our 35s here, which are yellow, which are represented by the submaster value. Our white value here, gray, which is 50, is the blocked value, a blocked value, and our red is in our live programmer value. Sort of the same thing on Hog. Like I said, the boards have different color combinations. A thing to note here on Hog is that when you're looking in this live output screen, you can quickly find, using this values, effects, sources, and plots button, you can find quickly where the information that's going to your light is coming from. If I clicked on effects, I would see what effects these lights were pulling their data from as they were running. So this is all these desks are multiple list desks, which means we can run many cues at the same time. And the playback sourcing can become confusing with so many cues running at the same time. A lot of times these desks have these spreadsheet views to help us out. I know Hog does and MA does for sure. Kind of click through that. And that's just a little zoom in. So here, these will be asterotubes, and they're actually running an effect here, that sort of thing. So want to talk, go ahead, Don.
Let's talk a little bit about submasters here, which can be a great way to quickly bring up a group of channels all at once. One submaster I always like to record is a lamp check, which brings everything up to 10% intensity. We can also utilize these banks as locations to place our cue stacks and playback and good storage of cues. So let's look at the EOS. This is one that probably a lot of people have seen, Submaster Bay. I always like having a physical touch item. These items we can represent on a screen, but I do like to have the physical block. So here's the digital representation, and all three consoles we've discussed today have their version of virtual faders that you can store items to. And Jared, how about you mention a couple of the functions that you can do with these submasters?
Oh, sure. Like Dominic talked about, you can have them. It's an easy way to like put an entire set onto a submaster, and you can bring that up, and then all the practicals you need to check for dimmer check are there. What I really want to highlight is the concept of an inhibitive submaster, which there's ways to do this on all three of the consoles lines and other consoles line. But inhibitive is basically the reverse of an intensity master. It's the fact that when you bring your inhibitor, you bring your inhibitor up, that actually is going to, I'm sorry, when you bring your inhibitor down, that actually kills the intensity or whatever attribute that you're working with that light. So I can inhibit lights by creating inhibitive submasters, which is helpful. A lot of people in settings do this for like when they're controlling fog machines, or like for me on set, I have a bunch of 20Ks that I don't want to leave cooking over lunch. I'll make inhibitive submasters for those 20Ks and bring those down, you know, at break time and that sort of thing.
Definitely. We'll take a quick look at the Hog's virtual representation of submasters. We see three buttons above the faders. It says play, pause, back, but really they can perform any function. And all these faders and submasters are very versatile tools that you can use. And we won't get into too much of everything that they can do, but let's consider them good places to put our Q stacks where we can store items so that we're not running everything out of a programmer. Say, I have an effect that I want to quickly run, like say at some point the gaffer calls for a lightning effect. Well, I might not put that in my main queue stack. Perhaps I'll put it on a second submaster so that every time I hit the button, lightning will go. And there's all sorts of gags and effects that can happen with that. So if you want an exhaustive list, we'll provide you an email with that.
And you can see here, as represented on the hog, there's a lot of different queue lists running down here, as well as some inhibitive masters. It's called a group sub on hog. So if I copied a group over to a playback fader over here, it would actually create an inhibitive submaster. So this is a concept we use a lot when I was filming concerts, where we would need to bring down the level for an entire performance of a certain group of lights, like like LED strip lights. We'd inhibit them all the way down to like 10%. And a quick way to do that was take my group of LED strip lights and stick them on the inhibitive master there and bring that down. So this is all virtual media server content. We'll talk about that a little bit later. I know we're getting close to running out of time here, so we'll kind of get through this stuff. Now we'll just discuss the basic writing of cues, which you will have to do, I'm sure, when you're subbing. So it's important to know the expectation of the gaffer and the primary board op when doing this on a regular basis. So don't walk in blind to your day. Like, know if you need to have fire effects going, or you need to have things as simple as light switch on, light switch off type of cues, which every show, no matter how complex, does a light bulb off, light bulb on type of gag. And you need to know how to label your cues. So talking about that importance of labeling, we can just see a standard little cue list I have here. And this is referencing our recording on Empire or Recording Studio 3 set that we have. I would typically write a walk-in look, which was just something that they could rehearse on as my first cue of each day, before I started manipulating anything for a shot setup. And then, my next cue I would record, and talking about recording cues, like, we're not gonna hammer on it, but we're gonna say it's as simple as hitting record cue 1, enter. After you've given your values to your lights, just record cue 1, enter. And then you're able to use time to manipulate the up and down fades of that certain cue, and the attributes of how that cue fades. But it can be as simple as just record cue 1, enter, label, and then you label it. And the talking about that archival idea or reshoots or this sort of thing, this is like, I like to label, this is referencing your call sheet, label the, so the 602.31 here, this is, episode 2 of the 6th season, and we're doing scene 31, and N1 means night 1 in the script. So scene 31, night 1. On the set, we're on Recording Studio 3, and then these were the characters, Devon and Tiana, that were involved in that scene. And this is actually the master shot we set up. So you can see that's my cue there. And then as we change the shot, each time, anytime you change a lighting level or a shot, you should record a new cue so you don't lose that information. That way, if they came to do a reshoot, we could go back to shot setup C of scene 31, and I would be able to call it up in the board, immediately. So in that way, like I said, it's great to label the cues like that. Easy recall. Usually your primary op is going to have night and day looks for our sets, or specific looks they use all the time. So you need, in your consultation, you need to figure out what is known and what is unknown for you stepping in that day. And here's what it looks, Q list looks like on Hog. Don't want to dwell on this too much, but again, it's the same idea of labeling, labeling your scene and just knowing where you are in your Q list.
We'll talk about palettes and pools here really quickly.
Yeah, so on a set, more often than not, like we've been talking, we're using LED fixtures with tunable color. So you need to be able to quickly assign color to your fixtures, and palettes are the way to go, or pools as they're called on MA. As discussed, you can set attributes via the encoder or wheels, but more often than not, when setting up our show file, the primary programmer will have laid all this out for quick access for you.
Well, I'd like to skip this slide and go on to the next one just because I really like this slide. This is my favorite slide probably in the whole presentation, and it's Jared's color directory, and it's just absolutely gorgeous. So to create this directory, Jared captured his set of fixtures, dialed in the color level, record, and then tapped an open pool. And the general organization of this pool is just great. We see that Jared can capture a fixture and instantly turn it red, green, blue, cyan, magenta, yellow, no color at that top. We see a list of standard color temperatures that he decided on in the second line. We see some unique color pools in that third line. Moving down, we see some common amber gels like that high sodium or urban sodium that get used for lights all the time. At the bottom, you see he can add magenta, or do your plus minus green magenta at the bottom there. And this is a slide like I'm probably going to copy in my pre-programming, like almost cell for cell. Like it's just a fantastic way to organize your thoughts on a specific parameter. So definitely an item to do when you start doing your pre-programming. So you'll have an intensity or dimmer directory that you might build up a little bit, but definitely build up your color directory because that's something that's wildly essential in film, of course.
Right. And I'll say it spawns all the industry, but the specific thing to note about like building color palettes is that there's different ways to do so. The fact that there's things like universal palettes or per fixture palettes, or so you basically have to take fixtures that have different attributes and create them into the same palette if you want them to mix to the same color. So it's a deep dive, and we're not going to get into that too much, but know that there are differences. I can't just tell all my lights to go to red, and they will specifically unless you've entered that information in the palette. For instance, if you have like a moving light, like I talked about way back with the dichroic color filter is the only way it has color, you need to program that dichroic color filter channel wheel to go to the red color and then put that into the palette. It's not going to just color mix to red magically because you called it red, or anything like that. But thanks for the shout out, Donna.
Oh yeah.
Again, here's a look of my shooting package on my EOS show file. So this refers to that concept of the snapshot I've been talking about a lot, and it's to quickly recall blocks of different info. So remember all the color palettes we just saw in the Hog? Well, here they are on the EOS, right? Check it out. They both match. It's the same color palette is there. And if I had an MA on this show I had to use, I would have matched them the same thing. That way I know, I always know what I'm dealing with. So up here we see my, oh yeah, we're gonna get to the last sort of subject here. Just keep moving.
Yeah.
The big one, the digital magic sheet. So we're talking about EOS magic sheets, Hog plots, and MA layouts views. So using digital magic sheets, plots, and layouts is a way to get real-time info and feedback from fixtures you're using in a graphical way. So it's easier than scrolling through your active instrument feedback. Really, it's the way of the world now, all the way to that grease magic sheet, on Broadway and rock and roll and film. It's all, everyone's using virtual magic sheets or layouts. You can add almost any attribute function attribute, function, button, soft key, effect, macro, anything you want, you could put on a magic sheet. So the world's kind of your oyster there. It's just about the time that it takes to create these, and it is a green way to cut back on your paper. So here is that graphical representation of my Empire shooting package, right? So the fixture types here are actually selectable groups. So here again, if I clicked on this S60, I would grab my first 6 sky panels, which I know are my S60s. Same with S120s and 360s. So that is a, you know, it takes a lot of time to build these things, and it's so user definable. You can do anything you want with it. And then here, I also use common macro commands like changing an intensity up or down 10%, which is something that's called for all the time. Bring it up a point, bring it down a point. So here I have 2 ways I can do that. I can do it either quickly here with my white button or slowly with my gray button. So if I'm actually live and in a scene and it's being recorded and my gaffer wants me to bring the light down 10%, I click on here and it comes down in like 5 or 8 seconds. I forget what my default was there. But so that's a way to do it. Also common line terminators like update as well as undo, which is a very great button that all consoles have, some sort of undo what you just did button. And so the next slide shows the real-time feedback from this magic sheet. So like I said, you're gonna see these from all the seasoned programmers. Colored feedback shows in block and palette above the fixture number. So I can see that my sky panel here is in a red color palette. It's color palette 1, and that fixture's at full. I can see that these standard 6x2.4K dimmer channels, which is probably some sort of wrap pack or onset dimmer pack, is all sitting at 15%. So you can see you get the real world value. And again, this is like that idea. I don't have to be on set to know what's going on. I can look at my screen and I see everything represented here. And I know which lights we're using from the shooting package, if that all makes sense. And also I threw some common color temperatures onto here that we were using, and that sort of thing. So that's building out a magic sheet, you know, very quickly. This is just another version of that, just taking a look at things. Same principles apply there. Here's an example of EOS pixel mapping over a 10 by 10 matrix. This starts to really dive into the advanced stuff, but we did want to mention like pixels here at the end because it's such a way that we're used to working now. Note that your pixel map will not read correctly on an EOS magic sheet without adjusting the interface of those channels. Viewing the content is on a pixel map preview, but I believe in their beta 3.0 they're changing that. They can, or ETC rep can tell me if that was the correct information to give. But basically pixel mapping, what we're talking about is the very last thing here, is mapping instruments or LEDs or pixels on an instrument to a space and using them basically as a low resolution video screen, right? So I'm taking this block of LEDs, RGB LEDs, and I'm playing this particular video effect file over it. So like the EOS magic sheet on the hog, this is a hog plot. It's the same type of idea. I can see color feedback and I can grab via fixtures via the touchscreen. So if I were using my finger to select this, I would be selecting this particular stereotube. You can see that all the pixels are on, though it's not giving me the levels. It depends on what software version you're running. That's an important thing to note too about what software version your desk is running. The function, each time they update the software on all these desks, the functionalities become more and more user-friendly and user-definable. So here, this is what the digital magic sheet on the hog looks like. It's basic and to the point. Represented here is a plot for 16 Astera tubes. Tubes are broken down into 4 sections of 4 pixels like I talked about. And I would also, you see this effect ran horizontally. I would also have plots made that would run the effect vertically. The gray box itself is the area for the pixel map to media to play in, and changing the size of the map, you can give different and desirable effects depending upon your needs. So you got to start thinking now not only are we lighting programmers, now not only are we the IT department, now we have to start thinking of ourselves as video people too, video engineers, because we have to start thinking about screen resolution and what that looks like playing over our lighting pixels. And a thing to mention about EOS and Hog together, and this, you'll have to tell me if it's the same with MA. These map functions and virtual fixtures do not need an address assigned to them in patch. You don't actually have to patch them on the EOS and Hog.
MA requires one address for a virtual video fixture.
Right. But for these virtual media servers, we're talking about like real media servers too that could have 100 attributes of control. Your keystoning, your gamma effect, all this type of thing. Like I said, it's a deep dive. This pixel map playing here, it's a rabbit hole, like I said, with pixel maps, but it is a really fast way to make a big impact and can make programming complex effects seem a breeze. Because you can see this, how would you take the numbers and create this circular video out effect? I mean, think how long that would take to kind of do that without just playing a video over it. So this is just 64 pixels having the video run over them. Here's the same idea with a different pixel map file running on it. You could achieve the same effect by using an effects engine and fanning out hue and saturation values. We didn't get so much into fanning and mapping like that for our, that's really a subject for advanced effect building. But you can see a complex color effect with the direction. It can easily rotate the map to flip it. So I could rotate it 90 degrees and flip my direction with a Z rotation. You got to experiment on your own with these. You can, and that going back to that whole time is money thing, right? On set, if you're tasked with creating like an effect you need to create, you need to spend time beforehand working on it, because you can spend hours and hours and hours working on one of these effects and really get bogged down in it. So you kind of just have to make a decision and run with it. The last example of the pixel map here before Dom shares his is this is just a theoretical fixture I created because we were shooting on location with a Ferris wheel, and I'm like, well, gee, I wonder how that Ferris wheel would work as on the pixel map and LED units. Like, how could I control this Ferris wheel myself? And so I basically looked at all the little pieces of LED that were on the Ferris wheel, and it came up with something like 400 fixtures. And I created a map with those on the Hog here and just mapped some basic content over it. And you can see how this kind of looks like the Ferris wheel in real life would be doing these effects, you know, like the one at Navy Pier or whatever, that sort of thing. So the point is to stay curious and learn something about these particular things. And Dominic's going to finish up with some MA pixel mapping here.
Yeah, so here's a quick file I did for a pilot that was going on before the shutdown, if we can hit play on that. And the plan was for several moving lights on the side, LED pars on each side, and then this massive wall of LED pars upstage. So honestly, when we get the pixel mapping stuff like this, it's almost like a low resolution video wall. And there's just no way I could program it to say Filmscape 2020 on a desk. This actually required a video server, which we can see in 2 slides. So this is actually the 3D, MA3D. Here's kind of our stick figures in MA2. And then one more slide, we see it mapped out in Resolume for this particular project. And again, you can import small resolution video files into the console itself, but a little bit more standard or professional ways to get a full-on video server. So some examples of video servers: MA has their MA VPU, there's PRG MBox, Unreal Engine, which I really want to learn, and Hippo. And again, this here is Resolume. So we have the ability to drive like just these massive pixel tape installations or other types of installations via video. Pretty much all of the newer, flashier nightclubs in the world, they'll definitely have, you know, an MA board or sometimes a Hog, but most often MA. But you simply can't get enough parameters in a single session of MA. I think MA2, your limit is 65,000 parameters. which sounds like a lot, but after you start adding pixel tape all over the nightclub, I think the last install I did was at Prism in Chicago. There were 140 universes worth of parameters, and we had to get Madrix, which is another great video pixel mapping software, to actually drive everything.
It's funny, Dominic and I didn't even talk about it, but it's a small world because on when we were doing Empire, we shot at Prism, and I
What?
took control of your rig myself. It's really interesting.
Yeah, yeah, it's one hell of a rig there. So, you know, video is definitely the next foray. I mean, look up Mandalorian, I think, and you'll just see like this cutting edge video stuff and how, you know, it's going to be video software that's driving lighting for a lot of these virtual reality type stuff. So,
And as that gig as our gig gets more complicated, you know, we are being looked to on film sets to, you know, we control all these devices, and the thing where we start to see rich man's process with the LED screens and all that's coming down to the lighting program now. So I know this is a basic class for starting out, but just understand the scope of how everything's changed, you know, from when it was just like light bulb on, light bulb off, and now we're all the way up to this media server stuff and that sort of thing.
do we have any questions at all before we give away some DMX testers?
Yeah,
You
we want
wanna
you to go
shout
live.
out and talk, or yeah, let's go
We
live.
want you to, you know, download these offline software, start using these consoles. You know, Dominic, you put my email address in the chat too, if you can. And then we just want you to have the experience using these things and start to be comfortable, so you can, you know, for talking to our electrician friends, you know, stepping up to be programmers, or those of you who are new to it, it's great to have, you know, to start getting that experience. So in closing, you know, do we have any Q&As, or we're good?
Not seeing anybody hopping in immediately. I'm gonna give a quick plug. We're about to hit an hour break before the next presentation, so be sure to go to filmscapechicago.com/exhibitors and check out some of our exhibitors.
Yeah, absolutely. And I just want to, on behalf of Dominic and myself, we want to thank everyone for attending this class, whether you came to just this session today or our session yesterday. And we hope it provided some insight into transitioning into the sometimes oversimplified world of the lighting programmer. We've had solid discussions throughout. We'd answer some questions. We're happy to remain in the meeting till all the questions are answered, but it sounds like everyone's pretty good to go. So we also want to thank, you know, Filmscape again, and IATSE 476, of which I'm a proud member, and hopefully Dominic will be a member soon. He's been working with us strong for the past year. We want to thank him for letting us put this on and get out there to you guys. And now for our final bit of business, if anyone stick around, we got some product to give away. Yeah.
Yep. So we'll be asking some questions here, and we'll need you to get your mouse ready in that chat window, or your cursor ready in that chat window, to type in some answers, and we'll be giving away a couple of these guys.
All right, here we go. Here's the first question. We can have 4 winners on this one.
Name one of the 4 universal parameters of lighting control that is shared by all consoles. Jesse Folks with the first answer there. Absolutely. Jesse, put your email in. Michael Kellner, color, absolutely. Put your email in the chat there and we'll get it sent out to you. Jason Muzzo with intensity. Name another one. We had intensity. We have intensity, color. There's 2 others. Hue is a virtual parameter. Beam, yes. Daniel, did you get one yesterday though?
Whatever.
Position, focus, absolutely. Okay. Yeah, Daniel did.
Okay, so we got them all.
That'll work for us. Yeah, Jason, throw your email in there.
Okay, so we got 4 winners there, and for the last one,
Nicole, put your email in there.
How many are we going to take on this last one? We can take a few.
Yeah, let's take Take 3 on these last ones.
Okay, here you go. Name a lighting console of your choice. What could be easier?
We got the Ion from Josh Lev. Josh, did you get one yesterday? Bradley, you got one yesterday. Michael, you already got one. Gary got the hedgehog. All right, I like it. Gary, put your email in there, as if I don't have it already. Yeah, SRE, Grand MA2, I like it. Toby with MA. Okay, we'll cut it off at there.
Okay, great.
So SRE, put your email in. Toby, put your email in. If you won one, put your email in because I'm going to be saving this chat, and that's how I keep track.
Yeah.
Scott, I got your email. See, Jason, you got your email in there. Sarah, you got it. Toby, I need your email still, I believe. And Toby, I got it in. Perfect. I'm going to go ahead and save this chat. Make sure I have it in my Finder because we want to give you all those cool prizes. Yep, we got it.
Cool.
Awesome.
All right. Well, yeah, guys, thanks again for coming out and get some lunch and enjoy some other cool seminars for this Filmscape thing. Thanks, Ned. Thanks, Filmscape.
Thank you guys very much.
All right. We'll talk to you in the future.
Thanks, everybody. Have a great rest of your day.